Hello, my name is Keshwani, that's K-E-S-H-W-A-N-I, Keshwani. I have been solving math problems for GRE out of this book here, practicing to take the GRE General Test, the 10th edition. If you do not own this book already, purchase one immediately. You're going to need it in order to prepare for the exam. It is the only book out there which has authentic real exam. It has 7 real exams, even though those exams are based on paper and pencil exams. But still, it is quite relevant because it is the same material, same people who are going to give you your exam. As long as you're taking the exam before the 1st of August 2011. On the 1st of August, the game changes. They are introducing a new GRE. Well, not the new GRE, but a new format of the exam. This would not change. What we are doing right now will remain the same. Quantitative comparison question will still be on the new exam, and nothing is going to change as far as this part is concerned, as far as this aspect of the exam is concerned. Anyway, enough of the talk. Number 15 is what we are about to do. The problem that I'm about to solve is the one that you're going to find on page number 342, quantitative comparison question, the very last one, number 15. As I said, because this exam that I'm holding in my hand in this book, they're all based on paper and pencil exam. In those days, and back in the old days, paper and pencil exam, all the questions were arranged in the order of difficulty, broken up into thirds. Since there are 15 questions here, the first 1/3 were easy, the next third, 6 through 10 were medium, and 11 through 15 are hard. Which means that by the time you get to number 15, the vast majority of the people will have trouble with this question. As a matter of fact, 70% of the people who took this exam got this question wrong. Let's take a look at it. So they give you a circle. Here is your diameter, P to Q. And how do I know that P to Q is diameter? Because it goes through the center O right here. They tell you in the problem that O is the center of the circle. If they did not tell us that O is the center of the circle, then we could not have taken liberties in assuming that O is the center. But they tell you right there explicitly that O is the center. And if O is the center, then this line that goes through the center is the diameter. And then they give you a picture like this. That's it. And they want us to compare the ratio of P to Q over R to S. They want us to compare this ratio versus 2 to 1. In other words, our job is to tell them whether distance P to Q is 2 times as large as R to S, this distance. If that is the case, if it's 2 to 1, then the answer will be C. If this distance P to Q is more than twice as much as R to S, if this P to Q is more than twice as much as R to S, then the answer will be A. If the ratio is less than 2 to 1, then the answer will be B, and so on and so forth. Well, not so on and so forth, that was the end of the story, because there are only 3 possible options. But there has to be an answer. The answer cannot be D. There has to be an answer here, because everything is clear-cut here. Everything is given to us. There is one piece of information missing. We need to know what this angle is. Otherwise, we cannot go anywhere. If without this angle, the answer will be D. Because if you ask me how much is R to S, in this scenario, the way it exists right now, my answer simply would be, how the hell do I know? It depends on how big that angle is. The extent of that angle will determine the length of R to S. So they must tell us somewhere. Angle ROS, angle ROS is the right angle. There you go, it's the right angle. Voila. That makes our life much simpler. So even though they do not give us the symbol here, but because we just learned that angle ROS is 90 degrees, I'm going to make a notation here. Right there. And the very first thing to do here, in order to keep our life simple, in order to make this question manageable, is to redraw this bloody thing. This bloody thing is drawn in a very distorted manner, extremely distorted manner. Let's redraw it, shall we? There we go. Because the pictures, what you have to understand is I keep repeating myself like a parrot, and if you watch other clips, the pictures, the figures that are given to you in this exam, in the GRE, are not drawn to scale. This is not the good old days, the exam that you took many, many moons ago after the high school, in your high school, in your junior and senior year, the SAT. In the SAT, all the pictures are drawn to scale. In other words, what you get, or in other words, what you see is what you get. For example, if I give you a triangle like this in the SAT, if the triangle is given to you like this in the SAT exam, then you can safely assume, not assume rather, you can know that AB, distance A to B, is less than A to C because it's less than, you can clearly see it. But if the same picture appears in the GRE, you cannot take that liberty. You cannot assume that A to B is less than A to C unless there is something in the problem that makes it clear. You can also not assume that this is a 90-degree angle even though it looks like a 90 degree. You cannot take those liberties in the GRE. Pictures are not drawn to scale. So unless you tell me that this is a right angle, I cannot assume that. So now they tell us that this is a right angle, even though it looks nothing like a right angle, because it's not supposed to look like it. As I said before, pictures are not supposed to look like what they are because they're not drawn to scale. There we go. Simple as that. Make a note of it if you did not know. So what we're going to do now to make this question manageable is to redraw our own picture, which is a little bit more sensible. This angle does not look like a 90 degree to me, does it? It's a very narrow angle. So I'm going to draw it and I'm going to change things around so that it's easier. What happened to this marker? Let's pick up a different marker, shall we? This marker all of a sudden does not want to cooperate. Because it's a 90 degree angle, I'm going to make it very simple. We're going to draw a 90 degree right there. Voila. Continue this here. And this PQ is my PQ right here. P to Q. R to S, which faces the 90 degrees. This is 90 degrees. R to S is this right here. R to S. Oh, in that case, the S and the Q would be the same in this case. You see, it does not show it. The way I drew it here, your point S is the same as point Q. I need to make a room here, right here. This thing is, the point is same as point S, because R to S, which is this right here, facing at 90 degrees. This is 90 degrees. R to S, it faces it, which happens to be the same as point Q. I hope it does not bother you. I had should have left enough room there, but anyway, that's what that is. Well, P to Q is very simple. It's the diameter, which is let's see. Is there anything else that they give us? No. Diameter, which is simply 2 times the radius. 2 times the radius. Our job is to figure out R to S, which is same as R to Q. Well, we know that from, let's call it O to Q. O to Q is the radius, which we are calling R. This is R. And O to R is also radius. So I'm going to reproduce this right angle triangle down here. Right here, this is R, this is R, this is 90 degrees. How do we figure out this side? Oh, very simple. With the Pythagorean theorem. Pythagorean theorem says R squared, this thing, R squared plus R squared equals the length of this side. Let's call it X squared. So R squared plus R squared is 2R squared, which equals X squared. Divide both sides by 2. R squared equals X squared over 2. And finally, R would equal square root of X, or rather, we're solving for X, aren't we? We're solving for X. So X squared equals 2 times R squared, and therefore X equals, take the square root of both sides, it will become R times root 2. R times root 2. And for those of you who know this thing, this is basically a 45-45 angle. Because this from here to here is R, which is O to Q, and this is O to R. And since O to Q and O to R, they are both radii and they are equal to each other, since this side equals this side, it's an isosceles triangle. And if it's an isosceles triangle, this is a 45 degree angle. This is 45 degrees, and this is 45 degrees. And for those of you who know it, in a 45-45 right angle triangle, the sides are in a ratio of 1, 1, 1, root 2. So R to S, as we said here, is R times root 2. Root 2 times R. And since R appears in both top and bottom, R drops out. And this ratio that we're looking for is 2 over root 2. What do we have in the second column? In the second column we have 2 over 1. In column B, so that's our column A. This is our column A. In column B, we have 2 over 1, it's just 2. So is this, we have to figure out, is this quantity less than or more than 2? Let's put it here. Column A and column B. Column A is 2 over root 2, and this is just 2. Obviously 2 divided by something more than 1, root 2, we don't need to know what it is, it's 1.4, about 1.4, but we don't need to know what root 2 is. Whatever it is, we know it is more than 1. So 2 divided by something more than 1 has to be less than 2. Because it's 2 and you're dividing it by something more than 1. That quantity, whatever it is, works out to be. We don't have to figure it out, but whatever it works out to be has to be less than 2. That's all. And therefore the answer is B. That's all. That's it, we're done. That's it. I hope you found it helpful. If you wish to get hold of me for personal private tutoring, face-to-face tutoring, I also do tutoring over the internet via Skype, and I also tutor over the telephone. If there is anything at all that I can help you, go to my website at www.for4gre.com and send me an email. You can also go to www.KeshwaniPrep.com and send me an email. Alright? Thank you.